Hello, namaste everyone. This is Electron X here once again, and now it's finally time for a Raspberry Pi project. This project will be a very simple one, as simple as 1 plus 1, and it's going to be for those who want to get started in this domain. What we will be doing is we will use signals from our Raspberry Pi board to control a relay module, which in turn will control the switching of a light bulb. We will be writing a Python code in Raspbian OS to send signals to relay. And while doing this exercise, we will also learn how to set up the Raspberry Pi with Raspbian OS and a little bit on relays. This project will require a Raspberry Pi 4V board, a keyboard, a touchscreen, and its adapter. We will also be needing all these things. We will require one micro SD card for the Raspbian OS. We will require one SD card reader, one computer mouse, relay module with optocoupler, wires, one light bulb, main power supply, and a multimeter. Here is a small outline of this video. We will see how to download and set up the OS for Raspberry Pi board. What are the peripherals we need to connect to complete the circuit? Then we will set up the installed OS. Then we will have a brief understanding of relays. And then finally, we will write our code and execute it. So let's begin with the first step, which will be installing the Raspberry Pi imager, downloading the Raspberry Pi OS, and then burning it on a micro SD card. RaspberryPi.com software webpage for downloading Raspberry Pi OS and Raspberry Pi imager. We will be going for the Windows version. Once this has been downloaded, go to Operating System Images webpage. This will show a list of all the available Raspberry Pi OS versions. But we will be going for the first one. Click to download that. Once this has been downloaded, go to the folder location. Click on it and press install. Once this has been installed, we will choose our device to burn the OS, our operating system, and the Raspberry Pi device. I've already connected a 32 GB micro SD card, so let's choose that. Then Raspberry Pi device, which will be Raspberry Pi 4, and the operating system image that we have downloaded. Scroll down, you will see use custom, choose your Raspberry Pi OS and click on next. Would you like to apply OS customization settings? We won't be applying it, but let's have a look. What are they? We can set our host name, username, password for the Pi, our Wi-Fi settings, other services, and some options. Click on no, yes. It will write the OS on the micro SD card, verify it, and then after finalizing, we will be good to go. Once your micro SD card is ready, look at the back of your Raspberry Pi board. You will see a SD card slot. Insert your micro SD card in this fashion. After you have inserted your micro SD card, we will now have to connect all the required peripherals, all the peripherals that we saw in some of the slides. So let's go through them one by one and see how we should connect them. Connect the keyboard directly via the USB port, and if you also have a USB wired mouse, connect that also in the same way, but I will be using a Bluetooth mouse, and since we are going to use a touch screen, we won't be having any problem connecting that mouse to the Pi. Connect your screen using the 2-lane MIPI display serial interface port as shown here, and remember to lock it up once you've made the proper connections. Now, look at the back of your Raspberry Pi screen. You should also connect the 5V and the ground to Raspberry Pi's 5V output and the ground pins. Use the wires that I have shown you earlier. We will be using pin number 4 and 6 of the board. 4 is tied to 5V and 6 is the ground pin. After all this has been done, your screen will be fully connected to the Raspberry Pi. Next is the main and the final part of the circuit, the bulb and the relay module. Relay module has a total of 5 connections. So firstly, we will be connecting ground and VCC, For this, we will use Raspberry Pi's pin number 2 for VCC connection and pin number 39 for ground. Then, for switching off the relay, we will use GPIO pin number 37 and connect it to in 1. On the other side, connect the common terminal to one of the bulbs terminal, and the normally connected terminal will go to the mains power supply along with the remaining bulbs terminal. After we have made all the connections, we will have the complete circuit, and this is how it will look. We have our keyboard, the Bluetooth mouse, the Raspberry Pi touchscreen, the relay module with optocoupler, and the bulb, with appropriate terminals going to the main supply. We also have the adapter connected to Raspberry Pi, which is going to be connected to the main supply. And only after you have connected all the peripherals, the micro SD card, you should turn on the adapter. After you have turned on the adapter, Raspberry Pi will start and it will show a red light and a green light. On the touch screen, we will first see rainbow colors, then Pi will do some initial configuration settings, and then it will restart. Finally, you will see the Pi OS desktop, and it will ask us to set up the OS. So let's go through that. This is what you will see after your Raspberry Pi has turned on. So click on Next to set up the OS. Choose your country, your language, and your time zone. I'm just selecting any of them. Then click on Next. Enter your Raspberry Pi password to set up the screen, whether you want the black border on the desktop or not. Click on Next, then choose your Wi-Fi. You can skip this, but let's do that. You can do it later also. It's your wish. And click on Next, enter your Wi-Fi password, and finally restart. After restarting, you will have set up your OS and it's ready to do all the kinds of operations. Before actually starting to code, let's have a basic understanding of what a relay is, and then we can execute the project. So relays are switches that open and close circuits electromechanically or electronically. Relays control one circuit by opening and closing contacts in another circuit. There are two types. One is when a relay contact is normally open. There is an open contact when the relay is not energized. Another one is when the relay contact is normally closed. There is a closed contact when the relay is not energized. In either case, applying electrical current to the contacts will change this state. Relays are generally used to switch smaller currents in a control circuit and do not usually involve power-consuming devices, except for some small motors and solenoids that draw very low amperes. Nonetheless, relays can control larger voltages and amperes also by having an amplifying effect, because a small voltage applied to relay's coil can result in a larger voltage being switched by the contacts. They are either electromechanical or solid state. In electromechanical relays, contacts are opened and closed by magnetic force. With solid state relays, there are no contacts and switching is totally electronic. For example, if we use LED diode and a photosensitive transistor. Here are examples of electromechanical and solid state relays. In the first circuit, as soon as the switch turns on, the current will start flowing and it will make the coil active, which will turn on the switch in the second circuit, and the current will start flowing in the second circuit also. In the second diagram, as soon as S turns on, the current will flow and it will make the LED glow. When the light falls on the photosensitive transistor in the second circuit, the current will start flowing in the second circuit also. This is what we are going to use. It's sort of a combination of both of these circuits, and this is how its circuit will look like. It does not depict the actual circuit of the relay module, but it will help us to get a good understanding of the working of it. So first of all, we will apply the VCC and the ground signals and connect it to Raspberry Pi pins. Then using the GPIO pin, we will make the in1 as low. Hence it is low. The current will start flowing in this branch, which will make this LED glow, and then the light will fall upon this photosensitive transistor's face, hence turning it on. Due to this, we will have a biasing voltage here for this transistor, which will turn it on. And then the current will start flowing in this branch also, making this coil active. This coil then flip the switch in the secondary circuit, and as the relay is normally connected one, this flipping will break the circuit and this bulb will stop glowing. Now if we apply a high signal here, the current in the circuit will stop. The light falling on this transistor will also stop, making this transistor switch off. And then we will not be able to provide a biasing voltage for this transistor. We will make it off, and hence the current will also stop flowing in this branch, deactivating the coil, and then this switch will move back to its original position, which is normally connected, hence again completing the circuit, and the bulb will start glowing. So this circuit will be on when this is high, and when the in one is off or low, the circuit will break and it will be off. So this is a basic understanding. Now let's move on and start coding and execute the project. Just one more thing before moving on about the pins on Raspberry Pi. While writing our Python code, there can be two modes using which we can access the pins on our board. The first one is gpi.board and second is gpi.board.bcm. In first one, we access the pins using the numbers printed on the board, for example P1, P2, P9, P40, and so on. In second mode, gpio.vcm, we refer the pins by Broadcom SoC channel number. For example, GPIO2, GPIO3, IDST, and so on. Let's start coding. I've already written all the code, so let me just show you the containing folder and the file. Let's go inside this folder. There is a file called alternateonoff.py. We're going to open it with one of the editor. There are two, Genie and Thorny. Thorny is more for beginners and Genie has more functions. So we're going to use Genie here. It's a very small code with only 24 lines. The very first thing is to import the modules. We're going to import rpi.gpio and the time module for delay functions. Then we are going to clean up all the settings that were done previously on the pins. After that, we will set the pin numbering system for our board. There are two, gpio.board and gpio.vcm. As we have discussed before in the previous slides. In this project, we are going to use gpio.board setting. Then we will set the pin mode for P37 using gpio.setup command. It will be an output pin. And finally, we will run the loop, and alternatively, we will switch on or switch off the bulb while giving a delay of 2 seconds using time.sleep. We will be looping through 10 times, 5 times off, 5 times on. Then we will check what is the current state of the pin. If it's on, we will switch it off using gpi.output, gpi.low. If it is off, then we will switch it on using gpi.output, gpi.high. And this will go on for 10 times, alternatively is on and off, with a delay of 2 seconds in between. And finally, we're going to switch it off using gpio.low, and hence our program will be complete. Now let's move on to the demonstration of the same. Let's open the programming editor and our code and start running it now. It will be off 5 times and on 5 times. As it was on previously, so the first command will be off. And finally, it will be switched off. This completes our program. I hope you learned something from this video. I understand this was an easily implementable project so that people who want to start using Raspberry Pi can understand the basics of it. I will be increasing the complexity and level in my future videos for sure. And we will also be playing around with Arduino. Until then, stay tuned and keep learning. Please subscribe to my channel if you liked the video and don't forget to click the like button if you did learn something and also press the bell icon. Thanks everyone and have a nice day.